Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Adil binti Ghail Akmal. My metric number is 1154478. We are from Group E. We'll present about our project with the title Customer Targeting using K-Nearest Neighbors Algorithm. Our group consists of 3 members, which are Muhammad Hassan, Izul Ismail, and I, Siti Nur Adawiyah. So, we will go to the introduction first. Machine learning is a sort of artificial intelligence that allows software applications to improve their prediction accuracy without being expressly designed to do so. In order to forecast new output values, historical data is used to be input for the machine learning algorithms. Today, it is important for organizations to do a prediction into customer behavior trends and business operating patterns to help them establish better business strategies. This project focuses on machine learning by giving a data set consisting of customer profile and characteristics as for which they spend more or less. By using machine learning algorithms, we can find out which type of customer is suitable for us to target in order to get a higher market. As our project title is Customer Targeting using K-Nearest Neighbors Algorithm, so our problem lies in the classification problem. Hence, we will apply the single approach algorithm, which is the K-Nearest Neighbor Algorithm, which is KNN in R. Our dataset consists of 2,627 unique customer data and 10 attributes that are usable for prediction. Next is our project objective. First, we want to implement programming using R in making models for customer targeting system. Second, to study and understand the KNN algorithm. Third, to evaluate the performance of KNN algorithm. Then, our model objective are first, to select certain types of customer for higher market reach. Second, to learn the behavior of consumers that prompts them to spend more or spend less. Third, to predict customer buying behavior based on their features. Next is expected output. Based on the dataset obtained, we will be able to analyze and visualize the data using a suitable algorithm. For this data, we are going to evaluate the performance of single algorithms by using KNN algorithm. The accuracy of the model is to be expected, and thus we could predict the right group of the new customers, and the output will be the prediction based on the customer's background behavior. Okay, now I will talk about the literature review of this project. First, what is customer targeting? Customer targeting is the act of contacting a subset of the customer in order to re-engage them and increase the business sales. The dataset shows that the company has already segmented their customer based on their behavior, so we will use KNN algorithm to predict the right group of the new customers. Next is the importance of customer targeting. First, customer targeting creates brand loyalty. Consumers in a target market possess a number of qualities that make them more likely than other customers to be interested in the company's product. These factors can be demographic, such as gender, age, and income level, or lifestyle related, such as a desire to eat fast food or traditional food. Second is customer targeting builds interest. Promotional resources might be focused on a certain target customer, and the advertising message can be tailored to appeal to that set of people. For example, product B and C have higher sales than product A. These factors work together to increase the likelihood of brand loyalty. Third, customer targeting keeps firms competitive. The company can promote itself as an authority on the wants and needs of a target customer by focusing narrowly on that group. It can respond swiftly to changes in their interests or belief, as well as maintain a close check on competing companies' attempts to entice their customer away. For this project, machine learning that we use is K-nearest neighbors algorithm. KNN is a basic algorithm that retains all available examples and describes new data or instances using a similarity measure. The reason why we choose KNN is it is typically used to classify a data point based on the classification of its neighbors. K in KNN is a parameter that refers to the number of nearest neighbors to be included in the majority of the voting process. They are a guide to choose a manageable value of K. First, using the formula which is K equal to square root n, where n stands for the number of samples in the training dataset. Second is through cross validation, which will basically be taken from the training dataset. Then we approach the Euclidean distance method for this project, as it is considered one of the most popular methods in KNN. This method is used to quantify similarity. That's all from me, and I will pass this presentation to my friend Hassan.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Hassan Ashuri. My metric number is 1812627. So right now, I will continue the presentation for my part, which is about the experimental setup. So firstly, for the experimental, we will go to the dataset description. So for the dataset description, the content of the dataset consists of the profile and behavior of the customer that are segmented accordingly. We will use this dataset to predict the customer's buying behavior according to the type of market reach. For a project, we will use the KNN, or the K-nearest neighbor classification algorithm, to predict the customer buying behavior and such. So basically, you can see in this table, this is the data description for the dataset. So we have 11 column, the ID, gender, if I'm married, age, graduated profession, work experience, spending score, family size, verbal and segmentation. So basically in this column, so the ID, we know it consists of it explaining about the customer unit ID. Next, for the gender column, it consists of the both male and female. Next column is about the ever married. It consists of whether the customer are married or not, yes or no, whether the customer are married or not. So next, we go to the age. So it consists of the age of the customer. Next, graduated. So graduated is actually same with the ever married, which is it consists of whether the customer married or not, yes or no. So for the next column is about the profession. So the profession column is about the customer occupation. So for example, the customer maybe work as a doctor, as an artist, something like that. So next, we go to the work experience. So work experience consists of it's about the how many years that customer have as work experience. So the next column is about the spending score. So the spending score have a 3 rate, which is if low, average, and high rate. So next, we go to the family size column. It consists of the total family members, including customer. And var1 is about the category of customer anonymized. And lastly, we have the segmentation column. It consists of the customer segmentation. For it separated to the four segmentation, which is A, B, C, and D. Okay. So next, we will go to the data pre-processing. So our dataset is we get from the kaggle.com. So the format is in the CSV format, and the dataset has 8,068 rows and 11 columns. And for the dataset, we will go in the data pre-processing. We will go through step by step of data pre-processing, and we'll do some data manipulation to ease us on applying the algorithm. Okay. So for first step is we will go through the data cleaning. As you can see in this, firstly we will remove the empty data. As you can see at the diagram below, diagram at the slide, you can see that the work experience column and family size column have a null value or have a empty data. So we will use the uh, R to omit the null value. So we'll replace or we will replace the empty data with a zero value. So next process we will go to we will change the data type. We will change the data type. So basically the data type that we changed is column gender, column ever married, column graduated, column Spanish score, column var1 and profession column. And we will change the data type from the char type into the vector type, and then we will change it into the numeric type, because our algorithm can handle the vector type data, because in KNN it will in the certain stage it will calculate the Euclidean distance. So basically it need a new only the new it can only calculate with a numeric value. It can calculate with a vector or char type column. So after data cleaning, we will go to the normalization. So in normalization, we will use to shift some values into the range of 0 to 1, and we will align them with the normal distribution. In most circumstances, the units of measurement for data are removed during the normalization process. As a result, we will be able to compare data from various sources with ease using a z-score or t-score. Also known as the standardizing, feature scaling, standardizing residual, normalizing moments, and normalizing vector are just a few examples of how to normalize data. We related to employ the feature scaling method, often known as the min-max strategy in our circumstances. Only the characteristic that we have chosen are used in this data normalization method for our dataset. It is made up of a few columns that are arranged in a certain way. Okay, so as you can see, as you can see in this table, this after we will go the normalization process. It will change the attribute age, work experience, experience score, family size, and var1. You can see the mean one, the mean, the quartile 1, median, quartile 3, max, and mean are changed after the normalization stage. So next, we move on to the correlation. So after normalization, we will do a correlation test. So this correlation test is used to determine the strength of each feature in relation to the intended output, and the correlation coefficient of each feature is calculated. The Pearson approach is used to map the correlation between each characteristic and the goal output, which is default forecast of the feature. So I don't know you can see or not. Okay, this in this figure is about the correlation between all pair of variable in dataset in RStudio. So which means that we will calculate using R. We will calculate the correlation value for all the column, all the pair of the column. So You can see the segmentation will pair. As you can see, the segmentation will pair with the gender, will pair the ephemery and all the column in that data set. So that this table explaining it about it. Okay. Sorry about that. Okay, next. Next, we go through. So this is the visualization about the correlogram for all available in data sets. So in this figure above, is known as the correlogram and adapted from the correlate function. Correlation coefficient for all pairing of variable are shown in the correlogram, with more vivid colors for more severe correlation, which means that you can see that we have a blue color, we have a wait we have blue color and red color. So if the more darker the blue, the more the color blue go into the dark, the more the value of the correlation will go to the positive number. While when the color of the column, column more to the red, it show us that the value is intended to the negative value. So basically, as you can see, we have the most darker blue one, which is the ephemerid and the age, which means the ephemerid and the age show that it have a most correlated value, while for the ephemerid and the spending score, it show that it has less correlated value because it have a darker rate than other column. Okay, so done for the correlation test. So next we will go to data visualization. Okay, so the data visualization is about the graphical depiction of information in data, and is known as data visualization. Data visualization tools make it easy to examine and comprehend trends, outlier, and pattern in data by employing visual component like charts, graph, and maps. So in our data visualization, we have used the Tableau tools for make our visualization more understandable and more easy to read. Okay, right. For the first for the first graph, it is about the bar chart of profession versus customer. So basically, as we can see in this graph, it show that the most customer, regardless of profession, tend to spend low, and the highest number of the customer is in the artist profession, uh, which the majority spend low while running up close to spending average. Okay. Next graph is about the bar chart of customer count versus spending score. So this visualization goals is to show that most customers who spend low are both male and female. But accurately, it is male who dominate in spending low. Male spending low, you can see. So, but accurately, it is male who dominate in spending low. Okay. The other two are also similar, ranging male customer to spending more than females. Okay. Last graph for the visualizations part is the graph is all about the bar chart of customer counts versus age group. So in this visualization, clearly show that customer at the age of 21 and 32, 21 and 32, spend the most compared to the other range. It spend most compared to the other range. And the highest to spend high in the customers in the age range between the 32 and 42. Okay. So I think that all from me. Sorry for my bad English language. Okay, we will move on to the next presenter. So thank you. Assalamualaikum.
Assalamualaikum, and thank you to my previous group mates for explaining previous things. Now it is my turn. My name is Izo Ismail bin Ibrahim, metric number 1817963. I'm going to explain about model development. So, next slide. As you can see, the model development consists of the flowchart for the k nearest neighbors algorithm. So when you see at the flowchart, it starts and then we load the dataset which we take from the customer segmentation, and then we use data preprocessing, for which we will clean the data from any noisy data and outliers. Then we extract any feature where we want to select, which we will undergo feature selection. And also after that, we will apply normalization as part of the KNN algorithm. Furthermore, we will split the dataset into test and training dataset by 2 to 8 ratio margin. For that, 2 is the test dataset and 8 is the training dataset, 8 out of 10. And then we compare, this is after we split dataset and then we want to do training on the dataset. We will compare the k values in which we initialize it to be 3 and also 4 based on our choosing. After we did the algorithm, we did the model in the KNN algorithm, we can finally calculate the accuracy of the KNN model based on our dataset. And that is when our algorithm is finished and coming to the end. So that is the model development. Next. Now we're going to modeling. Ignore the menu. I'm sorry, maybe I'm sorry. Okay, moving on to modeling. So modeling, next slide. Modeling is we do this is the full code for the KNN algorithm, which is k nearest neighbor algorithm. So firstly, if you can see, the first step is to import library, where we import library deployer, library class, and also library caret for using the KNN algorithm class. So note that we're not using the KNN from scratch, which we should do, but however, when we try to code it, the accuracy we got is a bit different. That's why we have no choice to use but to use the caret library. And then the second step is to import full dataset, for which we only have one, which is the training dataset. We already margin it to 8.2. So the training dataset is train.csv. After that, we do the data preprocessing, which is we clean the dataset by removing any unnecessary features that we don't want to use for this machine learning model, and also we reduce any duplication of data, and also remove any data that we do not want to use, such as we drop the ID column so that we don't have use for the column, and that is finalized clean data that we use. And the fourth step is to convert all features that we want to use into numeric values, except for the ones that is undergoing segmentation. This is so that we can select certain features based on the numeric value that we want. The fifth step is to create normalization, where we apply normalization on features that we want to be trained. So firstly, we create the normalization function, and then we apply it. And when we apply it, then the next step is to split the dataset, for which we have training dataset from our full dataset. We will split it into train and test. As you can see, the training dataset, we take the first content until the 80th content, while the testing dataset we took from the full dataset, which is from 81 to 100, which is in the margin of 20. And then we label the dataset just so that we know which one is which. And then the next step is to apply the KNN algorithm function. So the KNN model, since we are using the library caret, we just put the parameters inside, so it basically have already the Euclidean distance, it already have the calculation already inserted into the parameter, so there's no need to do it from scratch since we are using the library. After we apply the KNN model, means that our model is almost done because we already calculate everything. So that is the last part, is to visualize, in which we construct confusion matrix, and also this model can calculate the accuracy of the KNN model based on our K value. So as you can see, we visualize the data using confusion matrix, and also we find the accuracy. Next slide. So yeah, when we apply normalization and everything, this is the result of the code that we did. We run one by one. So as you can see, the CF_KNN is actually the visualization of the confusion matrix, for which we get to see that four column, which is A, B, and C, and D, which is we selected the features before. And also we found the accuracy, which is 0.65, and by that we can by using the same library, we can get all the statistics, which is the sensitivity, specificity, and that's it. So for the precision and also recall, we manually calculate it. Okay, so that is modeling, and modeling in which we use the KNN algorithm. Now moving on to the last part, which is the result. Thank you. So next slide. So for the result, firstly, the coefficient matrix that we generate from the KNN model, this is the visualization, better illustration. So as you can see, from column A to until column D, this is the coefficient matrix, for which it is a multi-class coefficient matrix, since we are using 4 column, which is a 4 by 4 coefficient matrix. So with that, we need to carefully calculate the true positive, false positive, and true negative. So we get a more brief coefficient matrix, since this is n times n coefficient matrix. So now the table below the coefficient matrix is the result of our performance evaluation. So based on the result of performance evaluation, you can see that the sensitivity of 0.5825, we rounded in the decimal form, not the percentage form, implies that the targeted customer were correctly classified for about 58.5%. And similarly, the specificity of 0.88 implies that 88% of the non-targeted customer were correctly classified. This is why I said 0.88 and also 0.5825 is to indicate the decimal values that has been stated on the result based on the code that I've shown before. So also, alternatively, 12% of the targeted customers were put aside as unwanted, meaning that it's not specifically for the 12% of the customer. So the idea of rejecting the 12% of the targeted customer may be unacceptable, or also it may be a reasonable trade-off given the reduction in unwanted customers. So the algorithm that we use, which is the model, also managed to be 57.43% precise in its forecast, and 89% of recall, 88 in specificity. Yes, so the accuracy of KNN model is 65%, with the error rate of 35%. And that is the performance evaluation, and that is the result of our customer segmentation model. And all in all, from what I see is since our model has an accuracy of 65%, it may be less or it may be above, but since we are using KNN algorithm, which is the most simplest and also most popular classification algorithm, we think we can, for future works, we can get a better accuracy depending on the types of algorithm we are using, or maybe we can use a fusion algorithm where we combine some algorithms so that we can get a better accuracy. With that, we rest the project. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you.